Good afternoon, everyone. I'm Kreethana. I'm going to talk about the dairy industry. The dairy industry is very important part of food sector. It involves the production, processing, and distribution of milk and milk-based product. This product include milk, paneer, butter, cheese, yogurt, ice cream, and milk powders. Along with this product, they are also made byproducts like buttermilk, whey, which are used in other ways. Milk is considered as a complete food because it contains essential nutrients such as protein, fat, carbohydrates, vitamins, and minerals, especially calcium. The dairy industry is not only contribute to human nutrition and food security, but it also supports rural livelihoods. It provides employments and it promotes economic growth. With modern technology like pasteurization, refrigeration, and advanced packaging, the industry which ensures the product safety and quality. It also keeps evolving with innovations offering functional, fortified, and lactose-free products to meet the needs of today's consumers. This picture inside the dairy industry, this is milk production. Now let's talk about the dairy processing. In the dairy processing are generally divided into two categories. First one is milk, fluid milk processing, and another one is industrial milk processing. Fluid milk processing, this involves pasteurization and processing of raw milk to make liquid milk for direct consumption. Other products include cream, flavored milk, and fermented products like buttermilk and yogurt. Second one is industrial milk processing. This industrial milk processing only focus on making value added products. Example, cheese, casein, butter, milk powder, condensed milk, whey powder, and ice creams. This is the picture shows the fluid milk processing, and this is the picture shows the industrial milk processing. This is called xylose. Inside xylose, the milk is processed. And next, let's look at the first steps of dairy processing. First one is raw milk collection, reception, and storage. Milk quality starts at the farm, and milking should be hygienic. And the milk is chilled below 4 degrees Celsius immediately after milking, and kept cold during transport. Collected milk is transported in stainless. This is a stainless steel tank to dairy plant. And next, separation and standardization. This is a separation machine. Centrifugal separation removes impurities and it ensures the uniform quality. And then milk is standardized. Standardization is nothing but is the process of adjustment of fat content in milk, protein, and lactose before making products. And after that, homogenization, we all know that it prevents fat from separating in milk. It improves the stability of product like yogurt done using homogenizer with high pressure pump and valves. And next, pasteurization is the process of heating milk at a specific temperature for set amount of time, which is used to kill harmful pathogens and make it safer to drink without significantly altering its nutritional values. There are two types of temperature which is used in pasteurization. First one is high temperature short time at 72 degrees Celsius for 15 seconds, low temperature long time at 63 degrees Celsius for 30 minutes. This prevent help this process help to prevent milk-borne disease like tuberculosis, typhoid, and fever and listeriosis. After that, cooling and storage. Milk is rapidly cooled from around 37 degrees Celsius at 0 to 5 degrees Celsius storage within a few hours. Stored in refrigerated stainless steel tanks at 2 to 4 degrees Celsius. This tank keep milk fish fresh, prevent bacteria and avoid spoilages. And cooling and storage, it ensures the milk is safe from the farm to processing plant and ready for further processing. Milk is a nutrient rich liquid food which is produced by mammalian gland of female mammals to nourish their young, containing essential nutrients like milk contains protein, fats, carbohydrates, minerals, and some of the minerals like calcium, potassium, and some of the essential nutrients, vitamins. Now, when we look at the commercial milk production, the process starts with raw milk collection from farm. Then it goes through quality testing. In that quality testing, they test uh, acidity test, pH test, salt test, and moisture content and ash content test, shelf life test, before being transported to the processing plant. In that quality test, they also test the MPRT test. At the plant, the milk is clarified to remove impurities, standardized to adjust the fat content, pasteurized by heating to kill harmful bacteria, and homogenized to break fat globules for a smooth texture. And this is the flowchart of milk production. First, the raw milk is collected in dock. Then it is goes through a filtration and testing to remove the dirt and check the quality. Next, it is cooled and stored to keep it fresh before further processing. After that, the milk is preheated. After preheating, the next step is to standardization and pasteurization. Here, the fat content is adjusted and harmful microbes are destroyed. From this step, the cream is separated. The cream is separated, which is can be further processed into butter. After that, the remaining milk goes from homogenization. In that homogenization, where fat globules are evenly distributed, so that milk has smooth texture. After homogenization, then it is pasteurized again, and to ensure safety, after pasteurization, the milk is packed either milk is filling in bottles and milk is filling in pouches. After packaging, the it goes from sampling and testing to confirm the quality, and the milk is sent for storage and distribution. Second one is paneer production. Paneer is produced by heating milk and adding an acidic agent to curdle it. This process separates the curds, milk solids, from the whey like liquid. The curds are then strained and pressed into solid blocks to form a paneer. For the best result, we can also use whole cow milk or buffalo milk is recommended for high yield and creamy texture, rich cream and coagulated. And then some of the coagulating agents we used that can cause the curdling. Like first one is lemon juice, white vinegar, citric acid, and buttermilk or yogurt. The paneer shelf life around 1 month. This picture shows the paneer productions in milk industry. This flowchart for paneer production. First, we take the received cow milk and we should standardize up to 3.5% of fat and 8.5% of SNF. After that, we should heat the milk up to 90 degrees Celsius. After heating, we should chill immediately to 78 degrees Celsius. Adding of colostrum as per treatment. Addition of coagulant. We use citric acid 1% of milk. After addition of coagulant, the milk is coagulated. Allow curd to sink to bottom. The whey is drained and we got channa. Channa is nothing but it is a block of paneer. After that, pressing. In that pressing for 15 to 20 minutes. The pressing process is to remove the excess moisture content. After that pressing, chilling at 4 degrees Celsius for 2 to 3 hours. After we got paneer. Third one is butter production. Butter Butter is made from cream which is churned and worked until the fat separates. Butter contains about 80% of fat, and part of which is crystallized, and the ideal churning temperature is around 15 to 20 degrees Celsius. Butter can be made either from cultured cream, salt or sweet cream, and it may be produced with or without added salt. There are two types of butter. One is salted butter, another one is unsalted butter. And for good quality butter, the main requirements are: first one is flavor, and another one is shelf life, color and uniform texture, and fourth one is good quality and useful byproducts. The shelf life of butter is around 9 months. This is the flowchart of butter production. First first we take raw milk, and after the raw milk from ripened cream, We separate the raw skim milk and raw cream. After raw cream is arrived, we should pasteurize the cream and butter making churning. After working and mixing, vacuum mixing, and after that we got butter. In that, butter is stored in butter xylose, and butter is packaging and storage and distribution. In that working, we should separate the buttermilk. In that, buttermilk is used for making buttermilk drinks, cheese powders, cheese products and yogurt products. We In that, buttermilk stored in xylose, and pasteurization happens. After pasteurization, evaporation and drying. Evaporation is a process of milk is removing water under vacuum at low temperature. It reduces milk volume, increase solids, helps in making condensed milk and milk powders. And in that, we got buttermilk drinks and cheese products and yogurt products. After that, in this step, working mixing. In that mixing, we dosing the water, salt, culture. After that, vacuum. After mixing, after that final step, we got butter. Next, butter making from ripened cream. This involves a series of steps to separate the fat from the milk and form butter. First step is separation. In that separation, first milk is separated to obtain the cream, which is richer in fat. Second step is churning. In that churning, the cream is then churned, which agitates. It can causes it can cause which it can cause the fat globules to clump together and forming small butter grains. And the third step is churning and draining. Continued churning causes these small grains to combine into larger grains. During this stage, buttermilk, the liquid remaining after fat separation, is drained away. After that, last final step is working. Finally, the large butter grains are worked, which involves the pressing and kneading them together to remove excess moisture and consolidate them into solid block of butter. Fourth one is cheese production. Cheese is produced by coagulating milk protein casein in such a way that the milk solids and fat are trapped in a curd matrix. This curd is then consolidated with the liquid part called whey is removed. Whey mainly contains lactose and some of the soluble proteins that are not retained in the curd. This is the main steps involved in the cheese production. Simple process. First one is milk receipt and pre-treatment, standardization, pasteurization to kill harmful bacteria, addition of starter culture to develop acidity and flavor, coagulation to form curds, extraction of whey, cutting and cooling of the curd to improve the texture, after that salting for taste and preservation. Finally, the cheese undergoes ripening for around 6 to 9 months, which develop its flavor, aroma and texture. And this is the classification of cheese. There are four types of cheese. First one is very hard cheese, moisture content less than 35 degrees Celsius, on mature cheese and ripened by bacteria. Example is Parmesan and Romano. Second one is hard cheese, moisture content less than 40 degrees Celsius. There are two types of hard cheese, ripened by bacteria without hives. Example cheddar, ripened by bacteria with hives, Swiss. And the third one is semi hard cheese, moisture content around 40 to 47 degrees percent, 47%. Three types of semi hard cheese. First one is ripened principally by bacteria, and another one is ripened by bacteria and surface microorganism, and the ripened principally by bacteria, blue mold. And this is split into two, external and internal. In that, external example camembert, internal example blue. And then ripened by bacteria and surface microorganism, example limburger, ripened by bacteria, example brick. And the final type is soft cheese, contain moisture greater than 47%, and split two, ripened and unripened. Ripened example neofortel and unripened example cottage. This is the flow chart explains the cheese production. First, we take the collected received cow milk. After that, we should standardization process is nothing but adjustment of fat content. After that, pasteurization, cooling to 37 degrees Celsius, addition of starter culture like a 1:1 ratio, 2% W by V. After that, addition of rennet. In that rennet, adding 1.5% 1.5 gram by 100 kg milk for 40 minutes. After rennet addition, cutting of the curd and cooking of cheese curd around 37 degrees Celsius to 42 degrees Celsius in 40 minutes. The whey is drained and the cheddaring of the curd. Cheddaring is the process of curds are repeatedly stacked and turned, pressing into slabs to expel excess whey and develop dense, elastic, and fibrous texture. After cheddaring every 15 minutes, cutting the curd. The desired acidity at which curd will stretch in hot water, and after that pasteurization process 80 to 85 degrees Celsius for 2 to 3 minutes. After pasteurizing process, molding into shapes for cheese, and then immersion in chilled water around 8 to 10 degrees Celsius and brain dosing 20% stretch. After that, packaging and storage. And next we look at the ice cream production. In that ice cream production, ice cream is a frozen dairy dessert, we all know that, which is made from a mixture of. This mixture is churned and frozen dessert which is incorporated hair, giving the ice cream its creamy and semi solid texture. By standards, ice cream should contains at least 10% of milk fat, and sometimes eggs stabilizers or adds ins like nuts and fruits or chocolates are used to enhance the flavor and texture. There are many popular types of ice cream which is available in market. First one is chocolate ice cream, vanilla ice cream, fruit ice cream, nut ice cream, sorbets, custards, cassata ice cream, gulfi, rainbow ice cream, and mousse. The shelf life of ice cream around 2 to 4 months, which when stored properly in frozen condition, they are around minus 18 degrees Celsius. This is the manufacturing of ice cream. First, we should select the all the ingredients. After that, formulation of ice cream mix. In that formulation of ice cream mix, there are two types of ingredients we should take. First one is dairy ingredient and another one is non-dairy ingredient. After that, blending of mix. After that, homogenization of milk. In that homogenization process, there are two stages. First one is stage 1 2500 to 3000 psi, stage 2 5000 psi. After the pasteurization of mix, in that pasteurization of mix, there are two heating temperature we used. First one is low heat low temperature long time 68.5 degrees Celsius for 30 minutes. After that, high temperature short time 80 degrees Celsius for 25 seconds. After pasteurization, we should cooling the mix at 4 degrees Celsius. After that, aging of mix, aging at for 24 hours at 4 degrees Celsius. Aging is nothing but is the process cooled mix is left to age, preferably for a period. And then after aging, we can add the flavors like chocolate, vanilla, fruits, butterscotch, strawberries. After flavor addition, we should mix and freezing ice cream. After freezing, packaging of ice cream and then hardening. Hardening at minus 18 degrees Celsius. Hardening is nothing but it is the hardening of ice cream facilitates stacking of ice cream packages during storage and transportation. This is the curd production. In that curd production, uh, lactic acid fermentation. Here, milk is inoculated with a starter culture of lactic acid bacteria. In that lactic acid bacteria, which is converted to lactose into lactic acid, and the increase in acidity makes milk protein coagulates, and it gives the curd semi-solid texture. After that, the main steps involved in curd production is milk pre-treatment, pasteurization or boiling method. After that, inoculation with the starter culture. After starter culture, we should incubation at a warm temperature for about 35 to 45 degrees Celsius, cooling and refrigeration to stop the fermentation and preserve quality. In that curd, we also called as dahi, can be classified in different ways. It consumed directly, used for making desi butter, and also preparing chakka and the srigant and lassi. It can be made from whole milk and skim milk, standardized milk, or special milk. Sometimes sugar or fruits are added for flavor. Finally, the acidity the acidity of normal dahi is less than 0.7%, while the acidity of sour dahi is more than 0.7%. This is the flowchart of curd production. First, we receiving the milk. After received milk is preheated at 35 to 40 degrees Celsius. After that, filtration and clarification process. Clarification is nothing but the milk is removing removal of the dust, feed particles, and epithelial cells and some bacteria from raw materials. In that, clarification process is usually done by centrifugal clarifier machine, which spins the milk at high speed. Heavier particles settled at the bottom. After clarification, we should standardization process. After standardization, preheating the milk around 60 degrees Celsius. After preheating, homogenization happens. Homogenization process. There are two steps of homogenization for especially curd production. Stage 1, stage 2 homogenization. After homogenization, we should pasteurize the milk at 80 to 90 degrees Celsius for 15 to 30 minutes. After pasteurization, we should cool the milk around 20 to 25 degrees Celsius. Addition of starter culture 1 to 1.5% in silos. After starter culture, we should packaging after packaging, the curd is incubated at 20 to 25 degrees Celsius for 16 to 80 hours. After, we got the heat and cooling and storage around 4 to 5 degrees Celsius. The seventh one is yogurt production. Yogurt is a dairy product which is made by fermenting milk with a specific bacterial culture. It gives a tangy flavor and creamy texture, and also it can be classified by texture, additives, fat content, or its milk sources. There are three types of yogurts. One is Kir yogurt and Greek yogurt, and the another one is fruit yogurt. This is the picture of fruit yogurt, and this also. This is the flowchart of yogurt. First, we take the standardized milk. After that, homogenization process at 55 to 65 degrees Celsius and 10 to 12 MPa. After homogenization, we should pasteurize the milk around 90 to 95 degrees Celsius for 5 minutes. After pasteurization, cool the mixture to incubation temperature around 40 to 45 degrees Celsius. After that, addition of starter culture 2 to 3%. After addition of starter culture, they are split into two two process. First one is set yogurt and the another one is stir yogurt. Set yogurt, the milk goes into cups and this called packaging. After that, incubation for milk turns into yogurt inside the cups. After that, cooling process, we got set yogurt. In that, addition of starter culture. After that, incubation, cooling and stirring process, cooling and pumping after packing, cool. After that, cold storage, we got stir yogurt. Final one is milk powder production. The milk powder is produced through a drying process. First, the milk is preheated, and after that, in tubular heat exchanger. After this, it is sent and evaporated. In that, evaporated to increase the concentration of total solids. After, the level of concentration depends on the equipment efficiency and how much heat can be applied without damaging the milk protein. Next, the solid concentration of milk is pumped into the atomizer of drying chamber. Here it is sprayed as a fine mist into the steam hot moving hair. Droplets cooled by evaporation never reached hair temperature. Preheating of concentrate to reduce the viscosity. In that initial drying, powder temperature powder moisture content around 6%, particle size less than 1 mm, and second drying in fluid bed, final moisture content around 2 to 4%. First type is whole milk powder, skim milk powder, buttermilk powder, and fat filled milk powder, whey milk powder. And this is the picture shows the skim milk powder. The flow chart for milk powder production. First, we receive the milk and we should select the selection of milk. After that, clarification process, and in that clarification process, to remove the dust, dirt, feed particles, and epithelial cells, some bacteria from raw milk. In that dust, dirt, all settle at the bottom of the machine. It sediments, and after clarification it should be cooled around 4 degrees celsius. After cooling it should be stored of raw milk 4 degrees celsius. After storage, standardization process happens. The fat content is goes out. After standardization, we adjustment of fat content. After adjustment, heat treatment happens at 90 degrees celsius for 3 to 5 minutes, or 130 degrees celsius several seconds. After that, evaporation of milk is removing water under vacuum at low temperature. It reduces the milk volume and increase solids, and helps in making condensed milk or milk, some of the milk powders. After that, it removes the water, the main process. After evaporation it should be homogenization, 15 MPa. After homogenization it goes through drying process around 130 to 150 degrees celsius, 180 to 24 degrees celsius. After that, the water is evaporated. After water evaporated it should be packaging and storage at 20 degrees celsius. After that we got milk powder, and we use the spray drying for milk powder. In that spray drying, concentrate into fine powders, fine droplets. Large drying chamber in with the hot hair, 200 degrees celsius. After that, spinning disc or high pressure nozzles are used. Droplets cooled by evaporation never reach hair temperature. Preheating, and after initial drying temperature of powder with moisture content 6%, and particle size around less than 0 to 1 mm diameter. Second drying around final moisture content around 2 to 4%. And this is the spray drying machines. This is the drying chamber. In the drying chamber we have a feed inlet. A liquid feed, the substance to be dried, is introduced into the drying chamber at the top of the chamber. This is hot air is introduced the drying chamber where it mixed with atomized liquid feed. Drying Drying, the hot air quickly evaporates into the liquid from the droplets, turning them into dry particles. This is moist air and particles. The moist air or newly formed dry particles exits the drying chamber and moves towards the cyclone separator. In that dried powder or transfer, the moist air is transferred the drying from drying chamber to cyclone separator. This exhaust, in that exhaust is used to release the air from the top of the cyclone. This tube is product discharge. The collected dry powder product is discharged from the top of the cyclone. Thank you.